A stress-strain diagram of the mild steel. The stress-strain curve is a representation of how much a material deformed under application of force. These are the following salient points can be observed from the stress versus strain diagram. Just see in this diagram there is a point indicated as A, B, C, D, E and F. A is the proportional limit, B is the elastic limit, C is the upper yield point, D is the lower yield point, E is the ultimate point and F is the fracture point. First of all, what is elastic range? In this range, the material is elastic in nature and the greatest stress up to which the material exhibits the characteristics of regaining of its original shapes and dimensions on the removal of load is known as the elastic range. And what is the elasticity? Elasticity is defined as the property of material by virtue of which deformation caused by the stress which is disappear on the removal of the load. And what is the proportional limit? It is the maximum stress level up to which the stress is directly proportional to the strain value. What is yield stress? It is the value of stress at which material continues deform at constant load. Now, what is the plastic range? After the elastic limit, a specimen undergoes deformation which cannot be regained with removal of the load. This deformation is known as the plastic deformation or plastic range. The region starting from the yield point to the end of the curve, that means from this point C to F, is known as the plastic region. And what is ultimate stress? It is the maximum stress induced in the specimen and it occurs in the plastic region. And one important point is there, phenomenon of necking. What is phenomenon of necking? During the tensile test, weaker section in the specimen which undergoes reduction in the cross-sectional area continues from the ultimate point, that means from the point E to the fracture point. This reduction in cross-sectional area of the specimen is known as necking, and this phenomenon is only occurs in the ductile material, and this phenomenon of necking does not occur in the brittle materials. Then what is the point F? That means fracture point. And what is the fracture stress? As the reduction in the cross-sectional area continues, the load bearing capacity of the specimen reduces gradually. At a certain stage, cross-sectional area of the specimen is so small that it cannot sustain the load and hence material or specimen is break. The stress at which the specimen breaks is known as fracture stress. In this diagram, the stress corresponding to the value point F is known as the fracture stress, and the stress value corresponding to the point E, that means ultimate point, is known as ultimate stress. Corresponding to the value point C is known as yield stress. Now in next video I will discuss the numerical problems.